All right, in this next video, we're going to keep going with factoring, section 4.4 of the grade 10 academic book anyway. We're going to be taking a look at two techniques. One is called sum of cross products, which we will take a look at later. But the first one we're going to take a look at is called a method of decomposition. And we'll get to that in just a minute. So the main concept here is that we're taking a look at factoring quadratics when the a value, that lead coefficient, is not equal to 1. It's a little bit more important. So we'll see how we get to that standard form by taking a look at an example of expanding. And this will also help us hopefully understand the concept of decomposition and see how it works. So with expanding, it involves the distributive property. So multiplying the terms there and then multiplying underneath, as you've seen before, to get this line here. No big shock there. And then we wind up with a simplified form. So if we start with factored form, we end with standard form, we call that expanding, or using the distributive property. What we want to do is take this expression and factor it to get that. Now you notice the lead coefficient, or the a value, is not equal to 1. Also, you should note that there is no common factor that is going to produce a 1 in front of that x squared, so we have a little bit more of a challenge here. So to take a look at how this technique works, we're going to focus on these two terms here. So how can the coefficients, that 8 and that 9, what are they connected to here? Well, they add to 17. So it looks a little bit like the simple trinomial technique with a equaling 1. This is what we refer to as a complex trinomial. And it looks like we have the same sort of idea, is that these middle two terms add to 17. But what the complicated portion is in the next part. So the coefficients of 8 and 9, how are they related to the 6x squared and the c value? That's the key thing here. That's the key thing. So we have to try and figure that out. Well, where does an 8 and a 9 come from if we use the number 6? That coefficient there. And the c value in line 3. Now the c value is a 12. So what does an 8, a 9 have to do with a 6 and a 12? Well, let's take a look. If I multiply 8 times 9, I get 72. Interestingly enough, it's also 6 times 12. So there's the connection. So the a value multiplied by the, I guess I should really do this one here. It's the a value and the c value multiplied to 72. And these coefficients also multiply to 72. So there's that kind of connection in here with all four of those values. So let's see how this method of decomposition works. And so what we're going to do is we're going to try to decompose the trinomial's middle term. That's what the language comes from. So let's take a look. So if we start off with the trinomial, a value not equal to 1, here's what we want. So we examine numbers using the a and the c, we get a 72. What we're looking for now is two numbers that multiply to 72, but these same two numbers have to add to 17. That's going to produce the same pattern we had up above. And those numbers happen to be 9 and 8. So again, two numbers that multiply to 72, and the same numbers add to 17. But where does this product of 72 come from? It's using the a and the c value from the original expression. So it's similar to that simple trinomial technique with one added step in here. So what we're doing is we're decomposing or rewriting the 17x into two terms. And why is it 8x and 9x? Well, those are the numbers that we use, positive 8 and positive 9. So this next step might seem a little bit interesting. Let's take a look here. So this is called factoring by grouping. So if we look at the first two and the second two terms separately, maybe I should underline those with a slightly different color here. All right, so we're going to take a look at these two and those two separately. All right, so between these two terms, there is a common factor of 2, and they both have x. Between these two terms, there's a common factor of 3. Now, what you're hoping for is that the remaining factor in the brackets is exactly the same. That's the way factoring by grouping works. So what that allows you to do then is say, well, the 3x plus 4 is the same for both, and the 2x plus 3 that were common become part of the other bracketed portion. And if you take a look up above, that's exactly what we had to begin with. So that's the method of decomposition. So we'll take a look at a couple more examples here. So we'll factor using decomposition. So again, you always want to consider there's a greatest common factor, and in this example it does not, because there's no number that divides into 6, 7, and 2 evenly. So the connection is here between the A and the C. So we're looking for two numbers that multiply to 12, and the same numbers have to add to 7. Well, that's fairly straightforward. Two numbers that multiply to 12 and add to 7 are 4 and 3. So we're going to decompose the 7x into two terms, positive 4x, positive 3x. And then we're going to do this factoring by grouping again. So this grouping, so we group the first two, we group the last two, and we'll look for common factors. So this has a common factor of x, and also you can divide both of them by 2. Now, there is no common factor in the second part, but we can use a common factor of 1 to help us get the other bracketed part that we're looking for. So 3x plus 2, if we common factor 1, we now get 3x plus 2 is common factor, common bracketed part anyway, and the remaining leftover piece, 2x plus 1. And that completes that example there. For this one here, off to the side, we're going to just take a look here. So we have 3x squared plus 8x plus 4. So again, we want to focus on multiplying the 3 and the 4 to get a 12. And then after that, taking a look at, well, what numbers multiply to 12? 2 and 6. But do those numbers add to 8? And yes, they do. So then we can decompose. So the decomposition there is going to look this way. Whoops, terribly sorry about that. Okay, so we're decomposing now the 8 into the plus 2 and plus 6 x terms. And then we're going to factor by grouping. So there's that underlined portion. So we're grouping those sets together. In this first grouping here, they both have a common factor of 3 as well as x, leaving x plus 2. In the second portion here, there's a common factor of 2, leaving x plus 2. And again, that's what we're looking for, that the first set of brackets in this step here, factoring by grouping, are identical. That will allow us to write the next steps. So there's the first bracketed part, x plus 2. The remaining leftover, 3x plus 2. And we have our completed factored form. And you can check both of those by doing a distributive property to make sure it does give you the initial results. We'll do 2 more examples. Just going to temporarily hide this one, just to make sure you get this concept. So again, we want to focus on here the 6 and the negative 10. So that's 6 and negative 10 give us negative 60. So we're looking for two numbers that multiply to negative 60, but they add to negative 11. Now that's a little bit more challenging. In this case, the numbers happen to be negative 15 and 4. So that might take a little bit of trial and error to get this to work. Okay, so that winds up giving you the numbers you're looking for. So 15 and positive 4 is going to be used to decompose the negative 11. All right, and then from there, we continue with the factoring by grouping. So again, this pairing and that pairing produces this pairing and that pairing, and notice the bracketed part's the same, very similar to the other examples. Okay. And the last one we're going to take a look at is up here. So once again, we're looking for numbers A and the C value, that's 6 and 6. We want two numbers that multiply to 36, but add to negative 13. So again, a little trial and error is going to be necessary, but in this case, the two numbers that multiply to positive 36, but add to negative 13 are negative 9 and negative 4. And then we follow through by the same process. We decompose using the negative 9 and the negative 4. Do the grouping, first two terms grouped, get a common factor, get that bracketed portion that we need, get a common factor. Now this is a little sneaky, so the common factor needs to be a negative 2 to ensure that we do get the same bracketed portion as we did earlier in this step. If you only used a positive 2, you wouldn't get negative. You wouldn't get the 2w minus 3. You'd get negative 2w plus 3. It's got to be exactly the same. So in the last step, so we use the bracketed portion as our first factor here, and then the remaining factor 3w minus 2. So that's decomposition. So it's a little bit of a sneaky technique. If you like it and it works for you, then go ahead. I'm going to show you another technique. Then I'll talk about one more technique that I actually have a YouTube video on my YouTube channel you can take a look at. We'll get to that in a minute. So this last technique, or the second technique, I should say, is called sum of cross products. Now, the way this works, it's a little bit more on the trial and error and a little bit less on the writing of the algebraic part. So you still need to consider factors, but here's how this works. In this particular instance, we're going to focus on the first term and look at the factors of 6x squared. Now, where does this come from? Well, it could be random. So we know that 2 times 3 will give us 6, x times x gives us x squared. We're also going to take a look at factors of the constant term, so the c value. Two numbers multiplied to 2. Well, 2 and 1 are probably the first ones that come to mind. So where the trial and error comes into play is here. So we want to be able to manipulate these factors in such a way that they produce 7x. Now, here's how this works and why it's called sum of cross products. So let's see if you understand. Here's how to check. So you line up the first two factors together, or this is one way to do it, I should say, 2x and 3x, and you cross them up. So notice how there is a cross going on here. So the 2x and 2 are multiplied together to get a 4x. So again, a crossing product, cross product. So cross the 2 and the 2x to get the 4x. Cross the 1 and the 3 to get the 3x. And then here's the word sum, sum of cross products. So we've crossed and product means multiply, and then sum means to add, and we get 7x. So we managed to find some factors that when we cross them and get their products, the results of their products sum or add to 7x, and 7x happen to be the middle term. So this one's a little bit more sneaky and it has a little bit more trial and error, and if the factors don't work, you try again. Now I'm going to show you a better way of writing this out. This is really a rough way of doing it. I'll show you a slightly better way in a moment with some other examples. So this particular one here, so I'm showing you the answer and we'll show you how the result, or sorry, that's the final factored form. Now, you might be wondering, how is it 2x plus 1 and 3x plus 2? Well, the grouping for the way this has been written is kind of a vertical technique. So it's the 2x and the 1 that go together, and then also the 3x, and the 2 that go together. And that's one way you can write it out. I'll show you an alternative way, see if this works for you. So again, here's what we want to focus on. We want to focus on the factors of 20x squared and the factors of 3. So let's see if you can get this to work out. So the factors here, so we want two things that multiply to 20x squared. Well, 10 times 2 will give me the 20, and the x times x will give me x squared. Now the convenient thing is it's always going to be x and x. Factors of 3, well, there's only really two options, 1 and 3. Now the order that you write these things down is going to be relatively important. And then we'll see why it's a negative all of a sudden. So if you happen to use 3 and 1, well, here's the trick. So we're going to cross product these. So the 10x times this number down here, and the 2x times this number up here. Now the sneaky part though is the results that we get, we want these to add to get a total of the middle term. So had we used positive results, 3 and positive 1, this would have given us a positive 6x and a positive 10. That would have given us a positive 16 when we add those together. Not what we're looking for. We want a negative. So we have to have a negative 6 and a negative 10 to produce the negative 16, meaning these need to be negative. So it's a little bit sneaky in the way it works, but you got to do some playing around. So whether you like this technique or the other one, it's completely up to you. We'll take a look at another example. So this one here, oh, I guess I should show you the final results. The final results, see the highlighted part, 10x minus 3, 2x minus 1. There's your final factored form. So you can read it straight across. It's a little bit different than the way I had it up above. Here I had it vertical. Here I've got a little horizontal. Might be easier to write it this way. 10x minus 3 and 2x minus 1. So in example B here for using sum of cross products, again, you're going to be looking at the factors of 3x squared. So 3x times x will give you 3x squared. And you're looking for factors of 4. So factors of 4. Now, I'm using positive 2 and positive 2 here. And then if you notice the arrow, again, I'm going to cross product these. So I'm going to cross this 3x down to the 2. And I'm going to cross the x up with this 2. So what that's going to leave me with is a crossing result. X times 2 is 2x. 3x times 2 is 6x. If I add these together, I want to make sure I get the middle term, and I do. So once I know that, I can highlight straight across with the ones that I did not cross with, and I get my factors. So the 3x and the 2 go together, and the 1x and the 2 go together. It's an interesting little technique. It does take some practice like anything else, and you have to decide which technique is going to work for you. We'll try another one. So again, we're looking for factors of 6m squared and negative 10. So 6m squared, well, the most convenient ones would be 3 and 2 to get the 6, and then m times m. Now we want a negative 10 here, so there's different options here. But the ones that are going to work for us, and I'll show you why, are positive 2 and negative 5. You want the overall result to be negative 11. So you can, if you mess around with the negatives, you really got to do like a little trial and error here. So again, we're doing this crossing technique. So I'm taking the 3m and I'm going to multiply by negative 5m. I'm going to take the 2m, multiply by positive 2, and I'm going to get these results. So I'm going to get a positive 4m when I do this multiplication, crossing down, or sorry, crossing up, and then crossing down gives me a negative 15. If I add those results, I get a total of negative 11, which is exactly what I'm looking for. Negative 11m. So how do I know what my factored form is? Well, there's the highlighted part to prove it. So that produces one of the factors, and this one produces your other factor. Okay. So again, this technique won't work for everybody, but you got to find the one that works for you. And one more. So again, looking at the factors of the first term and the last term. This is a little harder. So you got the factors of 18. 6x and 3x will give us the 18x squared. Factors of negative 28, positive 7, and negative 4. Now, it could have been negative 7 and positive 4, but again, you want to be able to do this crossing technique so that when you get your sum results, the sum is actually negative 3x. And why negative 3x? That's coming from here. So you're using all three of the terms, negative 18x squared to get these two factors, the negative 28 to get these two factors, and the sum of the results of the crossing and the product there is supposed to be negative 3x. So again, let's go through this. So your 6x is crossed down and multiplied by the negative 4 to get negative 24. The 3x is crossed up and multiply with the 7 to get positive 21. Add these together and you get negative 3x. So it does work. So I do know for a fact that the factors I'm looking for, 6x plus 7 is one of them. 3x take away 4 is the other. Okay, so it's a very interesting technique. It's not going to work for everyone, all right, but you have to pick the technique that works for you, all right? So either decomposition or sum of cross products, all right? And these last couple of examples demonstrate both. So on the left-hand side over here, there's decomposition, all right? So again, two numbers that multiply to, whoops, wrong tool, sorry. Two numbers that multiply to negative 10, add to 3. That's negative 2 and 5. So you decompose and then use the factoring by grouping technique. Okay, and then you continue the process. Now notice here there was a common factor as well, a little sneaky part in there. B over here on this side also has a common factor. Now even though this is the letter B, don't worry about that. It's still a trinomial, it's still a quadratic because there's a power of 2. All right. So in this technique, this is sum of cross products. So the reason why I was jumping straight to the answer is because the rough work is down here. Factors of 3b squared, factors of negative 2, we want the sum to be negative 5b. Factors of negative or positive 3b squared, factors of negative 2, we want the sum to be negative 5b. So after a little bit of playing around, I want 1b times 3b as factors for 3b squared. I want negative 2 and positive 1 for the factors here. Cross down to get 1b. Cross up to get negative 6b. Add the results together, negative 5b. This works. So I'm going to get my factors here as 1b take away 2 and 3b plus 1. Okay, so hopefully these techniques. And lastly, like I said, on my YouTube channel, there is another technique for factoring this type of trinomial. You can take a look at that video if you wish, and that's another technique that'll also work for factoring trinomials where the a value is not equal to 1. Just make sure you always take out a common factor like you had to do with these last two examples if possible before doing any of the techniques. So whether you're doing decomposition, sum of cross products, or if you happen to like the bottoms up, you can take a look at the associated video.